In the second part of 4.4, we're going to be, again, talking about the trig functions, the trig values of certain angles in degrees and radians, and now kind of applying the reference angle stuff that we talked about yesterday and using that to evaluate our trig functions. And then we're also going to dabble into solving trig equations. So example 6, it says evaluate the sine, cosine, tangent of the angle without using a calculator. Now, negative 495 degrees is not on the unit circle, but we know that we can add 360 to that. Negative 495 plus 360. That's going to give us a negative angle. Now, negative 135, if you know where that is on the unit circle, you could stop there, or if you need to do this again, add another 360 degrees, and we get 225, which is on the unit circle, but 225 also has a reference angle of 45 degrees, which means we know what the sine, cosine, and tangent values are going to be, but now we have to make sure we are in the correct quadrant. Well, 225 degrees, that's in quadrant number 3. Quadrant number 3, and our reference angle is 45 degrees. So then we know that the sine of theta, because it is a 45-degree reference angle, it's going to be the square root of 2 over 2, but because this angle is in quadrant 3, our sine value is negative. Cosine is also going to be negative square root of 2 over 2, and then the tangent is going to be positive 1, because in quadrant 3, tangent is positive. All right, then letter B, we have 15 pi over 4. Again, we got the reference angle is going to be pi over 4, because that's what our denominator is. So that's the easy part when it's in radians. But we have to figure out what quadrant we are in. So if we subtract a full circle, we get 15 pi minus 8 pi minus 8 pi over 4. That's 7 pi over 4, which we know is in quadrant 4. So sine theta is going to be negative square root of 2 over 2. Cosine, though, in quadrant 4 is positive, and tangent is negative in quadrant number 4. So then letter C, our reference angle is going to be pi over 6. And to get our angle at a full circle, we get negative pi over 6, which, again, if you know that negative pi over 6 is going to be in quadrant 4, you can stop there or add another circle, and you'll get the positive angle. So sine of the pi over 6 family is 1/2, but since we are in quadrant 4, it's negative 1/2. Cosine is going to be positive square root of 3 over 2. And the tangent, because we are, again, in quadrant 4, is going to be negative, and the tangent of the pi over 6 family is square root of 3 over 3. Right, so I want you to pause the video to answer these next two questions, letter D and E. And once you're finished, you can unpause it and see if we get the same answer. All right, so if we look at these answers, letter D, once I added 360, I found that I got 60 degrees, which is easy because that's in quadrant 1, so my reference angle was 60 degrees, and that allowed me to get those sine, cosine, and tangent values. Now, letter E, instead of adding one circle at a time, 6 pi over 3, I realized that I would have to end up adding quite a few circles. I said, okay, if I had 4 circles, 6 times 4 is 24. That gave me a positive angle that we are aware of on the unit circle, 4 pi over 3, which made the reference angle pi over 3 and made our angle in quadrant number 3. And then using the appropriate sine, cosine, and tangent values, 4 pi over 3, and then since we were in quadrant number 3, sine and cosine were negative and tangent was positive. So then let's look at example 7 here. A lot of the stuff that we did yesterday, but instead of finding all the trig functions, I'm just asking to find one of them. So find the indicated value of the trig, find the indicated trig value in the specific quadrant. All right, now example 8 is like some of the problems we did yesterday, so I'm going to go ahead and do letter A, and then I'm going to have you try letter B. So if the cosine is negative 7 over 3, we can draw that right triangle here. And cosine is the adjacent over hypotenuse, so let's go ahead and calculate that hypotenuse. 3 squared plus x squared equals 7 squared. So we get x squared is equal to 40, which can be rewritten when we square root that. X equals the square root of 40, which is going to be 2 times the square root of 10, because 4 times 10 is 40, and then we can simplify the square root of 4 as 2. So I think this may be the first time where we're able to simplify the radical. So sine is the opposite over hypotenuse. So 2 times the square root of 10 over 7, which means the cosecant is going to be that flipped. So 7 times 2 times the square root of 10. Well, we can't have that, so I'll multiply the top and bottom by the square root of 10. So 7 times the square root of 10 over 2 times the square root of 10 times the square root of 10 is going to give us 20, because the square root of 10 times the square root of 10 is 10, and then times 2 gives us 20. And because we are in quadrant 3, sorry, not quadrant 3, because we know sine is less than 0, so negative, we know that both of these, sine and cosecant, are going to be negative. Then cosine, we were already given cosine, negative 3 over 7, which means secant is negative 7 over 3. Tangent is the opposite over adjacent, so 2 times the square root of 10 over 3. And because sine and cosine are both negative, tangent will be positive. And then cotangent is going to be tangent flipped, so 3 over 2 times the square root of 10. Multiply the top and bottom by the square root of 10. That's going to give us 3 times the square root of 10 over 20. And again, because tangent's positive, cotangent will be positive as well. All right, so go ahead and try letter B, and when you're done, unpause the video and we can see what you got. All right, so here are the answers, and if you notice it says sine was greater than 0, so sine and cosecant has to be positive, but because cotangent's negative, that means cosine would have to be negative in order for the cotangent to be negative. So these would be your correct answers, except cotangent is going to be negative 5, because that's what we were given. All right. Now, example 9, we're going to use our calculator like we did the other day to evaluate these. Remember, we need to pay attention to the degree symbol to know if we're using degrees or not. So secant, again, is going to be 1 over cosine. I'm going to check my mode. I'm in degree mode. So 1 over cosine of 235. That gives me negative 1.7434. So negative 1.7434. Cotangent of negative 220 degrees, so 1 divided by tangent of negative 220 degrees, close parentheses, and we get negative 1.19175, which we'd round up to 8. So negative 1.1918. Now for letters C and D, those are in radians. So we're going to change the mode to radian and then do 1 over sine, because that's cosecant is 1 over sine, so 0.65. That gives us negative 1.6524. And then the cosine of negative 15 pi over 14 gives us the next value, problem for letter D. So our two answers, negative 1.6524 and cosine negative 0.9749. So the biggest issue with these calculator problems is remembering to be in the correct mode. Last thing we're going to do, which is going to be a little bit new, it says find the two solutions of the equation, give your answers in both degrees and radians, do not use a calculator. So the cosine of theta is negative square root of 2 over 2. So what we need to think about is when on the unit circle, so when is cosine equal to negative square root of 2 over 2? That's what we need to ask ourselves. Well, we know that the square root of 2 over 2 family is the pi over 4 or the 45 degree family, and cosine is negative in quadrants 2 and 3. So that means our theta in radians is going to be 3 pi over 4, which is 135 degrees, or theta could be 5 pi over 4, which is 225 degrees if we were in quadrant number 3. So there are two solutions to this equation because of how cosine is negative in quadrants 2 and 3. So just like how in quadratic equations we had two solutions, in trig equations, the ones that we're doing right now have two solutions dependent on the quadrant we're in. So now cosecant, if the cosecant is 2, well, that's saying that sine of theta is 1/2. So when is sine 1/2, positive 1/2? Well, that's going to be at pi over 6, which is 30 degrees, or in quadrant 2, which is 5 pi over 6, which is 150 degrees. And then lastly, the cotangent. When is cotangent negative square root of 3? If you aren't comfortable with your cotangents, you see, well, tangent's going to be the square root of 3, negative square root of 3 over 3. That may help you. That is the pi over 6 family. So that means theta would have to equal 5 pi over 6, or 150 degrees, because if tangent's negative, that means we are in quadrants 2 or 4. And then the other solution would be 11 pi over 6, or 330 degrees. So knowing that unit circle is critical for solving these trig equations. So thanks for watching this video. Make sure to like it and subscribe.